In the name of Allah, the most gracious, the most merciful, praise be to Allah and peace and blessings be upon the messenger of Allah, our master Muhammad, and upon his family and companions altogether. Now, after finishing the general discussion in the first episode and talking about it in the second episode, we start with you a new episode, a new challenge, and practical information that will benefit you in the job market about most of the teeth connections are in the form of a loop, meaning that the teeth wire goes from panel to panel. For example, the current flows from the CT to the GIS, then from the GIS to the LCC, and from the LCC to the protection panel or the volt recorder, etc. We need to understand that to transfer current from panel to panel, it must be done in series connection, because if it's done in parallel, the current value will be distributed, which is incorrect. On the other hand, transferring voltage from panel to panel is done in parallel connection. This is a fundamental principle in electrical engineering. We want to trace the current path and see how it moves correctly from panel to panel. We notice that the current will flow from 1S1 to CTX1 terminal 2, which is located inside the LCC panel. The current flows from 1S1 to CTX1 terminal 2 in the LCC panel. It moves from LCC to protection panel, X1 terminal 1, red phase winding, then to fault recorder panel, entering X2 terminal 2, which is located right inside the panel here. It's for local control circuit. Current flows from LCC panel to protection panel, into X1 terminal 1 to red phase winding, back to X1 terminal 3, then to fault recorder panel. It enters X2 terminal 2, goes to red phase winding, exits to X2 terminal 10, then X2 terminal 13, and returns to earth fault winding, exiting to X2 terminal 8. To the red phase winding, then back to transition. Inside the fault recorder panel, current enters terminal 2, goes to red phase winding, exits to X2 terminal 10, then to X2 terminal 13, returns to earth fault winding, exits to X2 terminal. Then the current flows to the volt recorder red phase winding, and then it exits from the volt recorder winding to X2 terminal 10, then to X2 terminal 13, returning to the earth fault winding inside the volt recorder, exiting to X2 terminal 8, exiting from the volt recorder panel and returning to the protection panel at X1 13, then entering the earth fault winding of the protection relay and exiting to X1 15, to return to the LCC panel at CTX1 7. And then going back to its source through CTX18 to 1S2. Notice that the city loop is now closed, with the current flowing as follows. From JS, current flows from 1S1 to CTX1 term 2 in LCC. Current flows from LCC to protection panel to X1, 1, and 3. Flows from protection panel to fault recorder to X2, 2, 10, 13, and 8. Current moved. Volt recorder, protection panel, LCC, GS. Applies to all phases passing earth fault winding, assuming zero current in yellow and blue. And then it returned from the volt recorder to the protection panel, again at X1, 13, and 15. And then from the protection panel, it went back to the LCC at CTX1, 7, and 8. After that, from the LCC, it returned again to the GIS to 1S2. What applies to the red phase should also apply to the yellow and blue phases. Notice that the current passed through the earth fault winding in the protection panel and the volt recorder, because we considered that the current value in the yellow and blue phases is equal to 0. If the current is balanced across the three phases, then no current should flow in the earth fault winding. We need to ensure this by injecting a balanced three-phase value into the red, yellow, and blue phases. For example, we inject 1 ampere into the red phase at an angle of 0, 1 ampere into the yellow phase at an angle of 240, and 1 ampere into the blue phase at an angle of 120, and make sure that the current flowing in the earth fault equals 0. From this diagram or drawing of the city connection, we need to understand that we have 4 cases. The first case is feeding the relay and the voltage recorder, which I just explained, and how the current flows within this closed loop from panel to panel. The second case is isolating the relay without isolating the voltage recorder. The third case is isolating the voltage recorder without isolating the relay. Here, isolation means removing it from the circuit during operation. The fourth case is isolating both the relay and the voltage recorder. As for the second case, it involves taking the relay out of service, meaning we bypass it while keeping the voltage recorder powered. So we open the first 3 TBs and close the fourth. For example, here we open X1 terminal 1, 2, and 3 and close X1 terminal 4. The same goes for the other phases and grounds. The current flow will be as follows. From 1S1 inside section S to CTX1 terminal 2 in the LCC, then to X1 terminal 4 in the protection panel, then to X1 terminal 4 in the protection panel, then to X2 terminal 2 in the fault recorder, then to X2 terminal 10, returning from X2 terminal 13. After that, it goes back into the protection panel through X1 terminal 16, then to CTX1 terminal 7 in the LCC, followed by CTX1 terminal 8, then to 1S2. The loop is closed from 1S1 to CTX1, then to 2 through CTX1 terminal 7 in the LCC, CTX1 terminal 8, 1S2, CTX1 terminal 6, X1 terminal 1S1, terminal 6, X1, 6, X2, terminal 6, X1. From X1 terminal 4 to X2 terminal 2, X2 terminal 10 to X2 terminal 13, X1 terminal 16, CTX1 terminal 7, CTX1 terminal 8, back to 1S2. Loop starts at 1S1, ends at 1S2. To 1, 2. Then finally back to 1, and notice that the loop started with B and ended with B, which means when the relay is isolated, the circuit remains closed. Isolating the voltage recorder while keeping the relay powered involves closing X2 terminal 1, X2 terminal 3, and X2 terminal 5, opening X2 terminal 2, X2 terminal 4, and X2 terminal 6. The current starts from 1S1 to CTX1 terminal 2. The current path will be as follows. And then open X2T, Y2T. As the current path will be as follows. And then open, the current starts as usual from 1S1 inside the GIS to CTX1 terminal 2, then to protection panel X1 terminal 1, then to X1 terminal 3. It then moves to the fault recorder at X2 terminal 1, then to X2 terminal 7, and then returns again to the protection panel at X1 terminal 13, and then to X1 terminal 15, going back to CTX1 terminal 7 in the LCC. Recorded to X, Twitter from the ON, and then X, Twitter from the, and then it goes back again to, and then returning to inside the CC, then to CTX1 terminal 8, and back to 1S2 in the GIS, closing the circuit. The fourth case isolates the relay and voltage recorder, the simplest case, by closing CTX1 terminal 135 and opening CTX1. The current flows from 1S1 in the GIS to CTX1 terminal 1, then returns to CTX1 terminal 8, back to 1S2. A crucial note, the single earthing point for all CTs is through CTX1 terminal 11. 2467. The current then moves from 1S1 in the GA to CTX1 terminal 1 and then returns to CTX1 terminal 8, back to its source again, 1S2. Here is a very important note that must be emphasized repeatedly, that the single earthing point for all CTs is through CTX1 terminal 11. Everything point for each CTs is through CTX1 terminal 11, CTX1 terminal 11. It's the closest earthing point for the CT, and it's important to emphasize that X117 inside the protection panel and X29 inside the fault recorder should remain open to avoid having more than one earthing point. Someone might ask, since I always keep them open, X117 and X29, why should I even have them? I could just remove them and save space for a terminal block. For example, let's say it's a facility that you might need someday, and it's not necessary to use it right now, but you might need it in the future. From what we've discussed, it was essential for the protection engineer to correct the designer's mistakes and bear the errors of those who came before. Speaking of corrections, the protection engineer should delete the mistake in green and correct it in red. Before I finish the topic on CTs, I should excuse one of the protection engineers on WhatsApp for his actions. Thank engineer Mohammed Serti for his book on vehicle testing and voltage. His book is among my references for this episode. And remember, Dr. Mahmoud Al-Jilani, a great electrical engineer, and his valuable book. We raise some above others in degrees, so some may serve others. The mercy of your Lord is better than what they gather. Join us next episode on earth fault and current protection. Until we meet again, may Allah bless us with minds that contemplate, wonder, find joy, and work. Don't you see man is always changing? What a mind that seeks guidance, asks, reflects, and thinks. And the mercy of your Lord is better than what they gather. Join us in the next episode on the topic of earth fault protection and current protection. Until we meet again, may you be well. God has given us an incredibly powerful mind to ponder deeply and wander freely and explore the vast and diverse world to find true happiness, meaningful work in it. Don't you see that man is always evolving, constantly changing and adapting? What an extraordinary mind that persistently seeks guidance, asks questions, reflects deeply, and thinks critically and thoughtfully. Our thoughts are inspired by the light of kindness and the abundance of knowledge that guides us. The ambition for goodness drives us, and we will express all our thoughts, shining a light on our goals to seek a life filled with more kindness, where we are affected and we affect others. God has distinguished us with a mind that contemplates and reflects, so our thoughts lead us and kindness calls us. We seek a life filled with more kindness, where we are affected and we also have an impact. God has distinguished us with a mind that contemplates and thinks, so our thoughts guide us and we seek goodness. God has given us a mind to reflect. Think wisely, my friends. Our thoughts inspire us with the light of kindness, and the abundance of knowledge guides us. The ambition for goodness drives us, and we will express all that is good. For a life filled with more kindness, we are affected and we also have an impact. God has distinguished us because we have a mind that contemplates and thinks. Our thoughts inspire us and we seek goodness. We move in our lives towards more kindness, where we are affected. And we also have an impact. God has distinguished us a mind that contemplates and thinks. Our thoughts inspire us and call us to kindness. God has given us a mind to reflect, and our thoughts guide us. We seek kindness in what we think. A mind that thinks. We are all united from everywhere. A nation's truly renaissance